fire, wind, and ice can dramatically alter a forest, bringing down trees and changing the habitat for both plants and animals. So too can insects, disease, and other forces of nature, and timber harvesting and other actions of man. But did you ever wonder what happens later, when the recovery powers of nature go to work? Take this stand. It was heavily logged 20 years ago, but you wouldn't know it to look at it today. Other trees have replaced the ones that were cut. Animals and birds are here, and the forest is growing, changing all the time. By understanding some of the natural forces at work, you can anticipate and even influence some of the changes. And you can get answers to important questions, such as, why do certain tree species thrive in some locations, but not others? Why are some species dominant? Why do certain birds and animals live in some stands, but not in others? What is the impact of timber harvesting on the land and the creatures that live there? We'll explore these and other questions, and we'll look at the principles of nature that explain them as we examine the changing forest. Well, there's lots of life in this stand, all kinds of plants and animals living together. And that's the first principle you need to know. This is a community, with each member finding what it needs to survive. Each interacting with others and with their habitat, each playing a role as the forest responds to a variety of conditions and disturbances, changing shape and composition. You see, a hardwood forest is a dynamic, ever-changing place. And with thoughtful management, you can influence some of the changes to favor the kinds of trees, birds, and animals you want. A forest is like a large house with several floors and many rooms in which activities vital to the community are accomplished. And that's another thing you need to remember. The community has a structure. At the top, like an attic, is the upper canopy, where the leaves of the dominant trees intercept some of the sun's rays and convert them into food for leaf and stem growth. In the eastern hardwood forest, the dominant trees of the upper canopy are often yellow poplar, oak, and maple. And because they capture most of the direct sunlight, they have an impact on the trees and other plant life which grow below them, and also on the kinds of food and shelter available to wildlife. In effect, the trees of the upper canopy shape the entire plant and animal community. The forest attic is a busy place. Caterpillars and other plant-eating creatures feed on the leaves. Warblers and other flesh eaters feed on the plant eaters, and larger creatures feed on smaller ones. This kind of food chain, with the hunters becoming the hunted, is found on all the floors and in all the rooms of the forest. Plants are always at the bottom of the food chain because they are the only organisms which can change the sun's energy into food. In the second story is the lower canopy. Trees that need direct light grow in the canopy openings, and those that tolerate shade, like dogwood and red maple, grow well under the canopy. Birds and small animals also make their home in the lower canopy, and nuthatches, brown creepers, and other creatures feed on its animal life. On the ground floor is the understory, where plants that grow in shade can be found. Rhododendron and striped maple, perhaps blueberries, and small shade-tolerant trees such as sugar maple. The makeup of the understory plant community is determined by the dominant tree species and the light and moisture available. Deer and other plant-eating animals may be present, as well as birds and animals that feed on both plants and smaller creatures. In the basement is the forest floor, an active and important place with herbs, ferns, and mosses, wildflowers, and other small plants. Large mammals forage here, as do a number of rodents, ovenbirds and other birds, ruffed grouse, and many other small creatures. On the surface of the forest floor, dead logs, fallen leaves, and woody debris called litter are in various stages of decomposition. And below this litter is a layer of decomposed organic material matted with the fine feeding roots of plants. The forest floor contains valuable nutrients as well as a bank of seeds that have been stored over the years, waiting for the right conditions to germinate. Enough seeds for the stand to reproduce itself. Dead plant and animal remains provide food for earthworms and other small creatures, and for microorganisms such as bacteria and soil fungi. These decomposers break down organic materials into basic nutrients that are critical for plant and animal growth: calcium, potassium, and others. Especially nitrogen, which is abundant in the atmosphere but available to plants only through the actions of the decomposers and certain bacteria and algae in the soil. If necessary nutrients are not sufficient in the soil, the farmer or homeowner adds fertilizer. But in a forest stand, natural nutrient recycling provides what is needed for plant and animal life. In addition to the actions of the decomposers on dead plant and animal life, natural weathering breaks down rocks, supplying such nutrients as calcium, and rainstorms bring in nitrogen and other ingredients. These nutrients re-enter the cycle, some reaching the roots of plants, some carried into streams, providing food for aquatic organisms and forest animals. This little black cherry will never develop well here in the shade. Black cherry requires full sunlight, and this one doesn't get what it needs. And this is another important principle. Sunlight is one of the basic limiting factors required by all plant and animal life, along with water, the right temperature, and certain minerals. And for each species, there is a range of tolerance. Too little or too much of the necessary factor can result in retarded growth and even death. When enough sunlight reaches the forest floor, plants flourish and compete with each other for available light energy. Those plants that need a lot of light, that are intolerant of shade, like black cherry and yellow poplar, grow well. When the forest floor is shaded, these shade-intolerant seedlings, some of our most valuable tree species, can't compete with others that produce adequate food supplies with small amounts of light. But as the canopy is opened, trees that require light get what they need to compete and develop. Water is another ingredient basic to plant and animal life. And like sunlight, there can be too much or too little. The trees in this beaver pond are dead. Too much water. This plant is wilting. Too little water. Temperature is also a critical factor, contributing to the existence of different plant communities at different elevations in the eastern hardwood forest. Red spruce, balsam fir, and mountain ash usually grow above 3,000 feet. Black cherry, sugar maple, and basswood between 1,500 and 3,000 feet. Virginia pine and river birch at lower elevations. The right temperature is also necessary for the germination of seeds. Pitch pine sometimes requires the high temperatures produced by fire, while walnut needs cold conditions for seed germination. Geography affects temperature. Oak grows at sea level in Maine, but not at 2,000 feet, though it grows at that elevation further south. Sunlight, moisture, and temperature work together to influence living things. On land with significant slope, the plant communities that develop are a function of all three factors, but especially moisture. Yellow poplar and sugar maple grow on moist, cooler, north or east-facing slopes. Chestnut oak and pitch pine on dry, warm, south or west-facing slopes. Willow and sycamore on wet, poorly drained sites. And unique plants like sundew and some beautiful orchids only at high elevations in bogs. Wildlife also have limited tolerance of these basic factors. Fish, reptiles, and amphibians are called cold-blooded because they have no internal temperature controls and must depend on their environment to provide a temperature range within which they can live and reproduce. A salamander's skin dries out if the moisture and temperature changes are too great. Snakes and other reptiles need sunlight to get warm. And brook trout seek out cool, shady pools and forest streams. The availability of nutrients and moisture in the soil affects tree and plant growth. Sugar maple will not reproduce on poor, dry shale soils in West Virginia, but grows well on moist, colluvial soils in the same area. Northern red oak, yellow poplar, and basswood need moist, temperate cove sites for best growth. Yellow poplar will reproduce and be competitive on most sites, though not on the poorest, while oaks compete favorably on poor sites, but requires that seedlings be already present on better quality sites. Not much left of this old farmhouse, but at least you can see that people once lived here. But what you may not realize is that until about 60 years ago, this land was a farm. Now it's reverted to what it was for thousands of years, forest. This is an example of another basic principle of nature, succession. Succession is the orderly process of change in a forest community. It's inevitable and, to a large extent, predictable. Scientists say that 5,000 years ago, most of the eastern United States was covered by forests, and most of the plant communities of the eastern hardwood forest were in place. Through the centuries, natural disturbances shaped the forest. Ice storms, wind throw, and fire, insects and disease not only created openings in tree canopies, but brought about changes in plant and animal communities and a diverse landscape. These old root mounds are all that's left of trees blown over years ago. Man also played an important role. By the time settlers came from Europe, many Native Americans were living in villages and engaged in widespread forest clearing. Their major tool was fire. They set fires to clear fields for agriculture and passageways for travel, to drive game during hunting, to get rid of pests, and to increase nut and berry production and so attract more wildlife. European settlers did extensive forest clearing as they established villages and farms. Their greatest use of wood was to heat their homes and cook their food, and after that, to build fences. Wood was also used to build homes, mills, factories, and industrial machinery, and to fuel steamboats and early railroads. Around the turn of the century, thousands of acres of forests were cut over and burned in the Appalachians. From the beginning of our country, its peoples used their woodland resources in different ways, some of which created major disturbances. However, natural plant communities reproduced themselves, creating the diversity of habitats found today. Whenever there's a disturbance, change occurs. The nature of the change depends on the community of plants and animals involved and how they interact with each other and with their environment. The forest that was here before this farm would have regrown quicker if disturbed by wind or ice or fire. Sprouts would have shot up from roots. But early farmers kept tilling the soil, preventing the forest from regrowing and keeping succession at the bare land stage. This old field has some lessons to tell us about how a forest is constantly changing. Let's look at the stages it passed through to become a stand like this, remembering that different forest communities respond in different ways to disturbance. When farmland is abandoned, the ground is bare and conditions harsh. Temperatures are high, moisture levels low. Pioneer plants begin to colonize the land. Weeds, herbs, and grasses, which can develop under these conditions but have a short lifespan. Blackberry, pokeberry, and fire cherry spring up. Sassafras and other species. Seeds are imported to the site. The wind may bring in the light seeds of yellow poplar. Birds drop seeds of black cherry and red cedar. And squirrels and chipmunks carry in heavier seeds like oak and hickory. In 2 or 3 years, plants like blackberry and fast-growing trees like sumac or fire cherry push up to capture the sunlight and crowd out the plant life that developed first. These pioneer shrubs and trees play an important role by contributing organic material and recycling nutrients on the site. The dense thicket of early vegetation provides a protective cover for many species of wildlife, including meadow mice and shrews, cottontail rabbits, grouse, and song and field sparrows. As the pioneer community develops, variations of temperature and moisture become less extreme, and conditions are created for the next stage of succession: the development of a plant community that requires a more stable environment and has a longer life. 10 years after the old field was abandoned, the once dominant grasses and herbs in this sapling stand are almost totally shaded out. Blackberries and other semi-woody shrubs, which grow rapidly for a short time, are nearly gone. And woody plants, which started slow, have become dominant. Yellow poplar, which requires sunlight and grows rapidly, soon rises above its competitors. In the understory, maples, beech, dogwood, and other trees which tolerate shade are developing, but slower than the yellow poplar. Some early successional trees are bearing fruit. Sumac and Hercules club can yield fruit after 5 years. Fire cherry after 6. Sassafras after 10. By contrast, an oak tree takes 40 years to produce acorns, but the forest floor has less vegetation, and the makeup of the wildlife has changed. Annual seed-producing weeds are now gone, as are the songbirds they attracted. Blackberry, an important food for bear and cover for cottontail and other animals, is also gone. Green grass and weeds are not as plentiful, and perhaps not as nutritious. But the fruit of fast-growing trees like sumac and fire cherry provide food for robins, as well as deer and turkey, ruffed grouse and chestnut-sided warblers. After about 25 or 30 years, the old field enters another stage, the pole stand. Now the canopy is closed, and most of the early successional trees with short lifespans have died out. Yellow poplar dominates the stand, and in the lower canopy, shade-tolerant sugar or red maple are developing, along with understory-tolerant trees like dogwood. The lower rooms of the forest structure are lost, and with them much of the plant and animal life once found there. Scarlet tanagers, blue jays, and red-eyed vireos are now present in the canopy, and ovenbirds on the forest floor. After about 75 years, the old field has become a mature stand. Yellow poplar remains dominant in the canopy, and shade-tolerant maples and beech form a lower canopy. Now the forest is relatively stable. All levels of its structure are restored, and lacking a disturbance, will remain so for some time. However, yellow poplar cannot reproduce. Since the dominant trees have closed out the sunlight, younger poplars need to grow. If a disturbance removes some of the yellow poplar, the maples and beech will replace them in the canopy. And if there is no disturbance, the yellow poplar will begin to die after 150 years. Either way, the shade-tolerant beech and maples, which can live 300 years, will take over the upper canopy. And since they can reproduce in shade, the beech and maples will remain dominant until a disturbance opens the canopy and succession starts again. Wildlife has returned to the mature stand with different occupants on different levels and in different rooms on the same level. In the upper canopy, squirrels, hooded warblers, and other animals consume the nuts and fruit. In the lower canopy, woodpeckers, raccoons, and other animals find cavities for homes. In the understory, flesh eaters search for food. And on the forest floor, animals that like hard mast have a well-stocked cafeteria. But while the mature forest offers room and board to a diversity of animal life, it is a fairly open place. The dense vegetation that gave protective cover to wildlife is gone, as is the abundant food of the pioneer species. They will not return until another major disturbance occurs. This example of old field succession is just one of countless possibilities. Other plant communities in different locations and conditions would produce different plants and animals, and even different stages of succession. But some things are common to all forests. None will just get old and stay that way. All will change. Sooner or later, with or without the intervention of man, the forest will reproduce, and the process of plant and animal succession will begin all over again. You can apply this knowledge of the changing forest to decisions about reproducing desired tree species and managing your woodlot. We've seen that temperature, moisture, and sunlight work together. And you may have figured out that some trees can use these basic ingredients more efficiently than others. Because of this, when you harvest a stand, you may not reproduce the same kinds of trees that were dominant before. To better understand this, let's look at 3 regeneration systems in terms of changes that can be expected. First, partial cutting. The removal of mature timber, singly or in small groups, usually every 10 to 20 years. Partial cutting creates a seed bed with low light and temperature levels, especially with single tree selection, and moisture levels comparable to those of a closed canopy. Decomposition of fallen vegetation is slow. Sugar maple is a tree that is suited to partial cutting on a good growing site. Its seeds have a high germination capacity, but don't live beyond the first year on the forest floor. Seeds germinate well at about 34 degrees, the lowest of any known forest tree species, and germination drops off rapidly as temperatures increase. The root sent out by the germinating seed has the strength to penetrate moist, heavy leaf litter and reach mineral soil. Seedlings are tolerant and can survive long periods of suppression. Beech does not compete well under an open canopy and is suited to partial cutting. It sprouts readily from stumps and roots and develops well in the shade. Beech seeds germinate on mineral soil or leaf litter, though not as well when the soil and litter are mixed. Shelter wood cutting involves the harvesting of mature timber over a period of years to encourage natural reproduction under the partial shelter of large trees. The technique involves preparatory cuts to remove dying and defective trees and undesirable species and prepare the seed bed, seed cuts to open the stand before seeding so that the light and heat levels needed by seedlings are available, and the removal cut to remove the rest of the mature stand so the young established trees can develop without competition. In shelter wood cutting, the amount of light reaching the forest floor and the seed bed temperature increase, but without excessive drying. Woody debris decomposes at a greater rate than in partial cutting, and the seed bed is broken up. Black cherry and the red oaks are suited to shelter wood cutting. Black cherry is intolerant of shade and requires a moist, stable seed bed. Trees produce seed almost every year, and the seed stays viable in the duff for 3 years. So many cherry seedlings get a start annually under a forest canopy. Under dense shade, as in single tree selection, black cherry can't compete with its neighbors. But in stands where all species get the same start, as in this removal cut, cherry quickly dominates its tolerant competitors. The red oaks, northern, black, and scarlet oaks, are tolerant of overstory shade and suited to shelter wood cutting when oak seedlings are present. However, understory competition is detrimental to oak reproduction. Germination occurs in the spring when the acorns are on or in mineral soil and covered by leaf litter. If not covered, they dry and lose their viability before temperatures favorable for germination occur, though black oaks are somewhat drought resistant. Clear cutting removes the whole stand in one cut. Reproduction usually involves sprouts from stumps or roots, small seedlings already present before clear cutting, and seedlings from seeds stored in the duff, dropped in the harvesting operation, or carried in to the site. After clear cutting, sunlight covers the forest floor. Temperatures on the seed bed are high and surface drying is rapid. Organic materials rapidly decompose, releasing nutrients for new growth. Pioneer plants rapidly colonize the area. A species such as yellow poplar is well suited to and can dominate reproduction after clear cutting. It develops in various seedbed conditions, but germination and seedling growth are better on mineral soil or decomposed organic matter than on thick litter that has not decomposed. The seedlings thrive in full sunlight. Whatever your approach to reproducing forests, you may have to recognize the presence of an already developed, persistent, sometimes even undesirable understory, one that will interfere with the reproduction of tree species you want. Throughout the range of the eastern hardwood forest, red maple is present in abundance. Tolerant of shade and a wide range of climatic and soil moisture conditions, it grows on a range of sites, from swamp borders to dry ridge tops. Red maple is a tolerant and efficient user of sunlight, moisture, and nutrients, and will develop in the shade of a canopy, ready to take over when taller trees are removed. You need to know what's in the understory, and if you don't want what's there, you need to take measures to eliminate the understory and postpone cutting until you can establish the species you want. Animals, birds, and other creatures are also active in the changing forest, and your partners in reproducing a stand. They help control leaf-eating insects that can harm trees and plants. They feed on seed-eating insects that can destroy viable seeds. They carry seeds and store them in ways that contribute to germination. And they pollinate many forest trees and plants. The changing forest is a busy place. As plants and trees compete with each other for growing space, and animals and organisms feed on plant life and on each other. And you can influence some of the changes if you understand the forces at work. The nourishment needs of trees you desire, the light, temperature, soil, moisture, and nutrients required, and the habitat needs of the animal life you want to encourage, their food, cover, and nesting requirements. By thoughtful attention to these forces, you can play a role in the development of the changing forest.